in this question it is given that if A alpha is the maximum value of An equal to this, then find alpha where n belongs to natural number. I have found that most of the students do it in this way. They say that differentiate both sides with respect to n, but that is not correct, because differentiation is allowed only if it is given that n is a real number. But if n is a natural number, it is not possible to differentiate it. Then how to do? For this, I will make you understand with the help of a simple example. Suppose the question is find the minimum value of n cube minus 8n plus 10, where n is a natural number. For finding the least value of this, I will not differentiate it because derivative of this with respect to n is not allowed when n is a natural number. What I do, I make a function fx is equal to x cube minus 8x plus 10, where x is any real number. And first of all, let us draw the graph of this. I will find f dash x. This is 3x square minus 8, and if I put it equal 0, x will be equal to plus minus 2 root 2 by 3. You must know that any cubic equation with coefficient of x cube positive, the graph always comes from below and finally goes up, and at the two values I get by putting derivative equal 0, at these 2 points the graph turns. It is clear that one value of x is negative, other value of x is positive. It means graph will turn 2 times, once on this side, second time on this side. And it is also clear that when x is 0, y is 10, that is, the graph will be surely of the type at second turning point, that is for x equal to 2, value of fx is positive or negative. By putting this value of x here, if I get positive number, it means graph will be turning somewhere above x-axis. If by putting this value of x here, I get the value of fx negative, it means the graph will be coming below x-axis and turn. That is, the graph will be of this type if at x equal to 2 root 2 by 3, value of fx is positive. And if at this value of x, fx is found to be negative, in that case the graph will be somewhat of this type. And here actual question was this, and n was a natural number. Hence the first thing is we can ignore the graph on left hand side, and on this side also x is not allowed to take any real value. Actually, because we are dealing with this, x can take the value only 1, 2, 3, 4 and so on. Actually the graph is of this type, that is, this turning point is having y coordinate positive. You can check easily by putting the value of x here. Actual graph is of this type. This point is 2. It is clear that this function becomes least for this value of x. But I can't say that this will be least for this value of x, because n cannot take this value. Hence what we do, I take the two natural number, one slightly less than this, other slightly more than this, and I find the value of this for those two values of n. It is clear that the natural number just less than this is 1, and natural number just more than this is 2. Hence, to find the least value of this, I will check the value of this at n equal to 1 and n equal to 2. Whichever is the smaller, I will say that is the least value of this. For n equal to 1, I get the answer. Answer is 3. And for n equal to 2, answer will be 8 minus 16 plus 10, that is 2. Hence for n equal to 2, I have got the answer 2. Therefore I can say the least value of this is 2 where n is a natural number. Same concept I am going to use for this question also. First of all, I make a function fx equal to x cube on x power 4 plus 147. Clearly f dash x is equal to x power 4 plus that is I get 3x power 6 plus 147 into 3x square minus 4x power 6 upon this is equal to 147 into 3 minus 4 x power 4 into x square upon x power 4 plus 147 whole square equal to x square into 147 into 3 minus x power 4 upon and if we put it equal to 0, this implies that x is equal to plus minus 3 square into 7 square whole to the power 1 by 4, that is x equal to under root 3 into 7. Minus will be rejected because finally I will put the value of x in natural number. That is why negative value of x is of no use. Hence I can say at this value of x, either it will be maximum or minimum. And it is also clear that if I take the value of x slightly less than this, it will become positive, and if I take the value of x slightly more than this, it will become negative. Hence I can say for this value of x, this will become maximum. But actually I have to find the maximum value of this where n is a natural number. Therefore n cannot take this value. In such a situation, find two natural numbers, one just less than this, other just more than this. Because it is under root 21, the natural number just less than this is 4 and the natural number just more than this is 5. Hence this will be maximum either at 4 or at 5. Put the value of n 4 also and 5 also and then see which one is the bigger value of an. That will become the required value of n. For n equal to 4, I get 4 cube on 4 power 4 plus, and for n equal to 5, I'll get 5 cube on 5 to power 4 plus 147. Therefore, we'll have to compare the values for n equal to 4 and n equal to 5. For n equal to 4, this becomes 4 cube upon 4 to power 4 plus 147. And for n equal to 5, it becomes 5 cube upon 5 to power 4 plus 147. I have to check which one is bigger. Otherwise, it is difficult to calculate. I proceed in this way. I suppose this is less than this. If I reach at correct conclusion, it means this is more than this. If I reach at a wrong conclusion, it will mean that this is smaller. I take inverse. 4 to power 4 plus 147 upon 4 cube is greater than 5 to power 4 plus 147 upon 5 cube. We know that by taking inverse sign of inequality changes, that is 4 plus 147 upon 4 cube is greater than 5 plus 147 upon 5 cube, and this means 147 into 1 upon 4 cube minus 1 by 5 cube is greater than 1. This implies that 147 into 5 cube minus 4 cube is greater than 4 cube into 5 cube. It is 147 into 5 square plus 20 plus 4 square is greater than 4 cube into 5 cube. It is clearly, and it is 8000, and it is 147 into 25 plus 20 plus 16, that is 61. Means this is bigger. Means I am reaching at correct conclusion. It means whatever I had supposed was correct, therefore I can say this is smaller and this is bigger. Hence I can say an is maximum for n equal to 5. Therefore the value of alpha is 5.